Let's have a look-see at the Proxxon Mini Mitre Chop, more prosaically known as the KGS 80. This is one neat little package that I believe is really well executed. Though either you know you need this saw, or you probably don't. Either way, stick around and I'll go through its externals, then its internals, do some test cuts, and see how she runs. Largely made out of cast aluminum and steel, this compact saw is pretty hefty at about 12 pounds. The only plastic to be seen is the blade guard and top clamshell. The base is cast aluminum and it is about 9 inches by about 9 inches, but for storage purposes, you got to add an inch or two on each dimension for you got a narrow shelf or something like that. Pretty easy to pack away though, because it is really compact. The actual work surface is not 9 inches. The actual work surface is about 7 1/4 roughly, and it sits slightly proud of the aluminum base. This is ground. The base is just raw casting. Even the saw unit is mostly cast aluminum, especially where it's needed, like in the hinge and this stopping. Aside from its diminutive size, what sets the saw apart from other saws is how it does its miter ring. The saw unit is fixed on the base, and it is the table itself that is able to rotate. Very nice positive stops to every 15 degrees so you can get all sorts of angles. The vise is one of the nicest features of the saw, being self-centering and with a useful step and a groove. The saw unit has a fine horizontal adjust to get the blade as close to the workpiece as possible, and that'll keep vibration to a minimum and help increase accuracy in surface finish. A work stop can be slid in for repetitive cuts, and I do believe that is the saw's strength, when you need to make lots of accurate, nicely finished cuts. The safety shield and the lockout are a little bit overzealous in my opinion, a la the European nanny state, and it doesn't allow you to view where the blade is going to be cutting, and it gets in the way of the workpiece. Notice how it's rubbing down here. Only thing I can positively say is at least once the saw is lowered, the lockout can be released and you don't have to hold it down for the whole cut. But this is going to be in the way, and unless you're an absolute klutz and you just want to prevent an accidental premature cut, this is just going to be annoying. Fortunately, the safety shield is easy to defeat. All you need to do is remove this screw right here, and notice the shield works still in the same manner. But you can lift it out of the way. You can see exactly now where the blade is going to be cutting before you do your cut, and then you can lower the shield and away you go. The included blade, it's 80 millimeters in diameter. It has 36 carbide tip teeth. It's not plugged in, by the way. Other blades include cut-off discs that you can get, like this one is 80 millimeter. Though you could use other 3-inch discs like this Lennox Diamond blade. I really can't recommend this one, however. I'll talk about that a little bit later on in this video. Alright, let's disassemble this thing. You know, if you don't take apart your shit, you don't own it. You're just renting it until it's broke. Particularly with this saw, because, you know, it's going to be creating a mess, especially if you're using these cut-off wheels. They're going to create a lot of grinding dust, and it's going to get all in the mechanism. So let's begin off with taking the top saw unit off of the base. Alright, rotate it around and figure out how to get the top off the bottom. Got some pretty big springs here and 2 rather big screws. I imagine that these need to be taken off and these screws can be taken off, and that whole top saw unit should come off as one piece. These springs are really quite strong and taut. I don't have any sort of a hook that'll get that nice and neatly, but I figure what should do the job just fine is if I was to remove these and just pivot the saw unit off of the base and open up this lower just to make a little bit of space here to get a hex key in. And there's one, there's two. Ball hex, really handy in this situation. Yeah, that's coming off well. One. There's the other. Now I should be able to just pivot the saw unit off of the base. Yeah, that worked out pretty well. And now we can take off the vise. This vise really is a thing of beauty. Yeah, I'm really enjoying these Asahi Japanese catcher ball hex wrenches. Check that out, ain't that cool? They got a little spring-loaded ball bearing in the tip that holds onto the fastener. Anyways, this vise is a thing of beauty. It's the nicest thing about the saw. No doobie about it. Just check that out. The step, groove, very well machined. Got some weight to it. Anyways, that's really cool. This is, look, it's already getting full of schmoo. You're going to need to take that apart occasionally to give it a clean and give that lead screw a wipe down and an oiling every now and then. Now that the saw unit's off, it's much easier to get into all these little nooks and crannies, and even the bowl. The saw unit really gets in the way of giving it a good cleaning. Back here you can see it's loaded with grinding dust. And I'll wipe. Now underneath, the work table is clipped on with a big arse Jesus clip. Got some circlip pliers here and rip her off. Yeah. Now, the table, you got a little flat washer here. The work surface, the work table should come out fairly easily. No, not too easily. There's a little bit of burr keeping it on. There we go. There we go. There's the work surface casting. Very nice. Fairly thin aluminum. I'd say it's a little bit more than a 1/16 of an inch, not quite an 1/8 of an inch. The base here is the locking, stopping thingamajigger, nylon tipped for locking the work surface and spot in place. And again, a very nicely casted piece. Aluminum. Recycle it. And on to the top unit. Let's remove the blade guards held on by this E-clip. Comes out relatively easy. Blade guard has a little metal wear plate there. Yeah, seems like it's polycarbonate there. You can see the wear from it not really clearing the workpiece very well. Now let's remove the blade. The blade, it doesn't come with a wrench. You gotta provide your own wrench. It's 11 millimeters. There we go. and it is sinisterly threaded, so go the opposite way. I remember what you call those things, and it holds the blade into place. There's the carbide blade, and there's the mechanism for the blade guard and the lockout, the safety lockout. A little spring here that provides some action there. Let's see if we can get that out before it goes off flying somewhere. Oh, there we go. Interesting that it's just loosely held in there. There's no nubbin on this side to keep it in place. I wonder if that could ever pop out on you. The spring is really easy to take out, and now that it's out, the safety mechanism can be defeated. The locking lever can be cocked downward, and now the saw is a lot less safe. In case that's your prerogative. Now let's unscrew the clamshell. These little stick magnets are really handy for fishing out screws. Let's do the reveal. Well, not going to give up its secrets that easy. There we go. Now, the reveal. And we find a very nice layout in here. Let's start at the power cord. Have a really beefy rubber strain relief and a black line and a white line. The black line goes to a micro switch to which the trigger depresses. It looks like all of the effort is being borne by these plastic pins, so you might want to be careful with not being too overzealous with the trigger. The micro switch is jibing, and it is rated at 15 amps at 125 volts. This little switch is making and breaking the entire electricity going into the motor and, well, the motor control unit, which is epoxied, and you got a black and a red line come out of there, and that would be for the big permanent magnet motor. And you got a negative there. Really big motor on that thing. Has bearing at that end, not a bushing, and a bearing at that end too. That's good because this belt is under tension. It's a toothed rubber belt. Already a lot of rubber dust in here, so it's shedding a little bit of material. So yeah, ball bearings are good. They'll resist the load from this belt. However, that motor is not going to be very easy to service. I see this end cap, it's staked on. So, interesting. At least the saw arbor looks like it can be removed relatively easy. There's a cap for pulling it out, so if you ever needed to replace those bearings, that would not be too difficult. No markings on this motor whatsoever. I have no idea who made it. At least the brushes are replaceable, it seems. Have a look at them. There we go. There's one brush. Huh. That's interesting. Looks like it's chipped off on the side. Huh. Anyway, it's a nicely laid out interior. Seems to be really well made. I'm not sure what this little control box is doing. It's all potted. At the very minimum, it's rectum frying the electricity for this motor, turning it AC to DC. Probably it's also doing some snubbing to protect the switch when it's being turned off. I don't know whether it has any soft start or anything like that. Who knows? I ain't gonna bother finding out. It's a very nice layout in here, very nicely done. And you can see that this safety lockout mechanism is clipped on with an E-ring, so you could completely remove that safety lever. That's nice to see. Anyways, that's the internals of this Proxxon KGS 80. Oh, one other thing to take a look at is the top clamshell. It is plastic, and see what sort of markings it has. It's ABS, it's basic plastic. Benchtop unit doesn't need to be anything more fancy than that, I guess. Again, very nice manufacturing. Check that out. The screws have inserts, have metal inserts. That's pretty cool. Let's put it back together so I can run some tests. Okay, let's start off gentle with no load. We'll see what the power requirement is. It's rated at 140 watts. Motor rating, it goes up and down how much it's actually using depending whether it's in load or not. I'll test it no load. That'll give you the minimum power requirement, and the advertising drivel says that it has a very quiet motor. Well, let's find out. The advertising drivel also states that the saw runs at 5400 RPMs. Let's see if at least that's accurate. 5400 must be the European spec motor. Okay, let's do some test cuts. Let's start off really basic. This here is just a wood chopstick because, well, why not? The saw is made for hobbyists, and I guess that's the sort of thing that hobbyists would be chopping. It's some sort of a soft wood, and let's just see what sort of a cut this is going to make. I'm using the included carbide saw blade. I got the safety protector in because I'm responsible. And just make sure that I'm going to clear the vise. Looks good. Whoa, did you see that thing fly off into the yonder? It's supposed to land in a bowl. Anyways, the key thing about the saw, I believe, is that it should leave a nice finish. And not bad, but this would need a bit of cleaning up. I chose this chopstick as a test subject because I knew that this wood would be not very easy to cut neatly. It's a soft wood. Maybe let's try something a little bit more challenging. Not a lot more. Here is a Lowe's brand, don't forget your Project Essentials, paint stirring stick thing. Again, a fairly soft wood. This is, I'll be shocked if it actually cuts nicely. It'll be a good demonstration of using that step. This is what the step is for. You can get these flat stock nicely located on the vise. Let's give this a shot. Hope that thing doesn't go flying. Not too bad that time. Let's see the quality of the cut. Much better. Yeah, I think that's really the strength of the saw. It's being able to make a cut really quick, really accurately, and the end result is basically ready to go. You don't gotta clean that up with a sander or some other technique. So that's the strength of the saw, cutting small pieces of wood. Let's try something a little bit tougher. Here's a piece of hard maple. It's a pretty big piece. I'm not sure that the saw is going to handle it, but let's find out. Crank that open. Crank, 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 crank. That's what I am, a crank. There we go. And where's that cutting? Okay, let's give this a shot. Not bad. I went a little bit fast at that. You got a little bit of charcoal in there, but that is a very clean cut with hardwood. Softwood, your results may vary, but with hardwood, not bad at all. Not bad. Okay, let's feed it something a little bit tougher. Here is a piece of aluminum, and I did not change the saw blade. It's still the stock 36 tooth carbide blade, and it's supposed to be good for aluminum and brass, so let's find out. A little bit slower than the wood, but once again, not a bad finish whatsoever. Not bad in that direction, and seems pretty good in that direction too. Huh, worked. Alright, let's do another test cut. Here we got some brass thin stock. It's a little bit less than 1/16 of an inch in thickness, and the width of this stock is, it's roughly 1 5/8, I would say. Why? Well, that's what the saw, I think, excels at, particularly with that nice step on the top of the vise. That's fitted in there. Clamp it down really good and tight, and let her rip. Not bad at all. That's pretty much ready to go into your project. Check the squareness. Yeah, square. And now I've changed over to the Proxxon 80mm cutoff disc, and I have here some hard piano wire. It's about 5/32 in diameter, a little bit more than 1/16 of an inch. See how this handles that. Sparky. This is a lot cleaner than using your hand nippers, but this is anything but perpendicular. The included 36 tooth carbide tip saw blade on brass, on aluminum, on wood did a reasonably good job of maintaining a nice square edge, but the cutoff disc, there's some sort of wandering going on here. Here's a piece of 1/8 stainless steel, I think it's 304 is the alloy, and I cut it with some hand nippers, and you can see what sort of a cut hand nippers give you. A rather rough cut. Let's see how the saw can handle it. Open up the vise a little bit so that it can fit into that groove, and tighten it down really good. There we go. Oh, hot. And here's the cut that it made in that stainless steel 1/8 stock. Cleaner than pliers, no doubt about it, but that is not straight whatsoever. That's got to be at least 10 degrees off a square. Okay, let's put it to work. Here is an insert bit end mill that I would like to dock down in size to make it like this other one I docked down in size some time ago. This bit, it is about 10 millimeters in diameter, and it's made out of some sort of a Chinesium tool steel SDK11 or something. I think it's supposed to be roughly equivalent to H13's tool steel. Well, let's give this a try. Fits in the vise nice and easily with that V groove. It should hypothetically get a nice straight perpendicular cut. Let's find out. Pretty sure that went above 94 decibels. Okay, about 10 minutes have elapsed, which is necessary because the cutoff wheel really does impart a lot of thermal energy into these pieces. Well, I can see, even without a square, the cut it's not square. It's just not square whatsoever. This saw, when being used as a cutoff saw with an abrasive disc, it's just not really suitable. You can see there with the square is a little bit of space in there. I'd say it's about 3 or 4 degrees off a perpendicular. Yeah, the problem is that the disc, the Ripums, it's only 5900, and it'll slow down when it's in actual use. A cutoff disc should be running a lot faster than this. And on top of that, the diameter is only 80 millimeters. That means the surface feet per minute actually at the cutting edge, or the abrading edge where it's working in the workpiece, it's not really fast enough. And I think that the cutoff wheels, fiberglass, it's a little bit flexible, it's deflecting and is causing these cuts in hard material to not be really ideal. We could see that here in the stainless steel thin diameter cutoff as well. Here's the piece that was cut off, and here's the piece that was in the vise, and not sure whether the camera's picking it up or not, but it's a little bit off of perpendicular. It's not perfect. However, when it does come to, let's say, thin sheets of brass, the saw works wonderfully. It just cuts really nice. This was in the vise. This was free. Really nice cut there. Aluminum. Again, this would be with the saw, not the abrasive disc. It did quite a good job of cutting. The piece that got lopped off has a little bit of a burr on it, but that's not too bad. This was a piece that was in the vise. And of course, when it comes to wood, well, then the cuts are perfect. They're really nice, ready to use cuts. Aluminum, brass, wood, away you go. Soft woods, your results may vary. Here is the piece that I cut, and I didn't notice this when I was filming earlier, but it did actually leave a little bit of a splinter there behind. Oh, it's kind of to be expected. Yeah, it's still a pretty usable cut, just with minimal work. Just a little bit of sanding touch up and that. So that's ready to go into your project. Anyways, this saw, again, you'll either know that this is what you want, and away you go, and you're going to buy it. If you don't know, hopefully this video helped show you its limitations a little bit, and it's really well made. It's a lovely tool, but it's not a jack of all trades. Frankly, for me, I prefer my bandsaw. I got a little hand bandsaw, a little mucky M12, little battery operated. You know, that saw, one blade cuts brass, cuts aluminum, cuts steel, cuts whatever the heck you want. This, you gotta change the blades and the cutoff wheels. Not so sure about that. Anyways, thanks for watching. Take care, and see you next time. Bye-bye.